Amethyst looks like something that should only exist in stories. But under all that purple light, it's still quartz, the same basic mineral as clear rock crystal, just with a very different journey. In this video, I want to stay grounded in the earth and follow how amethyst actually forms, how it grows, what turns it violet, and why some quartz becomes amethyst while other quartz stays clear. At its core, amethyst is silicon dioxide, the same chemical formula as clear quartz. What makes it amethyst isn't a different mineral, it's the story written into its crystal lattice. Tiny traces of other elements, and what happens to them over time. Most amethyst starts with empty space. Deep in volcanic rock, gas bubbles can get trapped as lava cools, leaving round or irregular cavities inside the solid stone. In other settings, cavities can form when minerals dissolve out of rock, leaving behind little hollow chambers. Thousands to millions of years, silica-rich water moves through the rock. That water carries dissolved quartz, along with tiny amounts of other elements, and slowly seeps into those hollow spaces. As conditions inside the cavity stay stable and the fluid cools, quartz starts to come out of solution and attach itself to the walls. Crystals begin to grow inward from every surface, pointing toward the centre of the hollow. Given enough time, you end up with a geode, a solid outer shell of rock lined on the inside with a forest of quartz crystals. When the right ingredients are present, that inner forest doesn't stay clear. It becomes amethyst. The purple in amethyst isn't painted on the outside. It's built into the crystal itself. While those quartz crystals are growing, trace amounts of iron slip into specific sites in the lattice. On its own, iron-bearing quartz can still look colourless. The violet shows up later. Once the crystal is in place, it sits in the earth for a very long time, surrounded by rocks that naturally contain tiny amounts of radioactive elements. Over ages, that slow background radiation gently changes the state of the iron trapped inside the quartz. That change creates what geologists call colour centres, places in the crystal that absorb certain wavelengths of light and let others through. To our eyes, that shift shows up as shades of lilac, violet, and deep royal purple. So the way I think of it is, quartz grows first, iron sneaks in while it's forming, and then time and natural radiation quietly turn on the purple. Not every quartz crystal with iron is destined to become amethyst. If there's very little iron present, or if it isn't sitting in the right spots in the lattice, the crystal may stay clear even after a long time in the ground. If the crystal never sees enough natural radiation from the rocks around it, those colour centres don't fully develop, and you still end up with clear or only very faintly tinted quartz. But underneath all of that, this is where it starts. In dark rock, quiet water, and crystals that took a very long time to decide they were going to be purple. Change any part of that story, and you get something else. Clear quartz if the iron or radiation isn't there in the right way. Pale, smoky, or other tints if the chemistry or conditions differ. Or yellow to orange tones when similar iron centres are altered by heat and move towards citrine instead. Amethyst can carry all kinds of little worlds inside it. Golden rutile needles, thin hematite platelets that shimmer, tiny bubbles of fluid, wispy feathers, or even other minerals like calcite and agate create banding around the edges. Those little black freckles you sometimes see in amethyst aren't dirt. They're usually tiny inclusions of iron oxide minerals like hematite or goethite, or small pockets where iron and other impurities have collected. From the moment a lava flow traps a gas bubble to the time that bubble is fully lined with crystals, we're often talking about thousands to millions of years of slow change. Crystal size depends on space, supply, and stability. If the cavity is large and the mineral-rich fluids keep flowing in at a steady pace, the crystals have room and time to grow into big, well-formed points. If conditions change quickly, the chemistry shifts, the fluid supply cuts off, or temperatures swing, growth stops earlier, and you're left with smaller, more densely packed crystals. So, when you look into an amethyst geode, you're looking into the fossilised remains of an ancient bubble in stone, a hollow space that spent ages slowly filling itself with quartz, iron and light. In the next videos in this amethyst court, we'll step out of the geology and into the energy, exploring how this stone connects to intuition, calm and the crown.